Using the law of sines, we need to show that in a triangle ABC, b times cosine b plus c times cosine c, that's equals to a times cosine of b minus c. Let us begin. First, we'll specify the law of sines. Now, the law of sines states that if we have a triangle ABC, where the sides opposite to angle A, B, and C are represented by the letters A, B, and C in lowercase, then we have the ratio of side A to that of sine of the angle opposite to it. This will be equals to the ratio of the sides B to that of sine of the angle opposite to it. And this is also equals to the ratio of the third side C to that of sine of the angle opposite to it. So this is the law of sines. Now, in order to solve this problem, we will consider that these three ratios be equals to a common constant, and let's call it lambda, such that we can rewrite A in terms of lambda as A equals to lambda times sine A. Then B can be represented as lambda times sine B, and C will be equals to lambda times sine C. Right. So we'll begin from the left hand side of a given expression. So here we have b times cosine b. So we're going to replace the value of b with lambda times sine b. So lambda times sine b multiplied to cosine b, plus we have c. So c can be replaced with lambda times sine c. We're going to get lambda multiplied to sine c multiplied to cosine c. Fine. Now what we'll do, we'll multiply each term with 2, and we're also going to divide by 2, and also let's take lambda as the common factor. We have lambda over 2 multiplied to sine 2 times sine b times cosine b plus 2 times sine c times cosine c. The reason why we wrote in this particular fashion, because we know for a fact that 2 times, we know this is a standard formula. So 2 times sine theta multiplied to cosine theta, so that equates to sine 2 theta. So we can now replace the value of 2 times sine b cosine b, this first term, with sine 2b. The second term is going to become 2 times sine c cos c will become sine 2c. Fine. Now we have the sum of two trigonometric functions. We're going to use the fact when we have sine theta added to sine phi, so this sum is equals to 2 times sine theta plus phi over 2 multiplied to cosine theta minus phi over 2. So let's use this formula. So we are going to now get, we have lambda over 2 multiplied to 2 times sine. So here theta is represented by 2b and phi is represented by 2c. So we're going to get sine b plus c multiplied to cosine b minus c. So 2 and 2 gets cancelled. So we're left with lambda times sine b plus c multiplied to cosine of b minus c. Now let's work with the angle sine of b plus c. Now we also know for a fact that the sum of the interior angles of a triangle A plus B plus C, so that equates to pi radian. Now that means B plus C will become equivalent to pi minus A. Now we will take the sine of the angle on both sides. So we have sine of B plus C, so that will be equals to sine pi minus A. Now sine pi minus A, that gives us sine of A. Now we can say that sine of B plus C, this will be also equivalent to sine A. So we can replace the value of the sine B plus C with sine A, such that we get lambda times sine A multiplied to cosine of B minus C. Now we have already defined this value. So we know that A equals lambda times sine A. So we can replace it with A, and this is going to finally give us the value A times cosine of B minus C. And this is the expression on the right hand side. We started out with b times cosine b plus c times cosine c, and we got a times cosine of b minus c, hence proved.